let f of x be 1 minus ax to the power negative a half. Prove by induction that the nth derivative of f is equal to this expression. N is positive integer, n is 1, 2, 3, and so on. So we start as usual with the smallest possible value for n. It's 1, so we write for n is 1. And the first derivative from the function df over dx is equal to what? We can see that it's something to some power, and we should apply what? Chain rule. And it says that we should apply the same rule as for x to the power negative a half, and it becomes negative a half, this 1 minus x to the power negative a half minus 1, which is negative 3 over 2, and multiplied by 1 minus ax derivative, which is what? Just negative a. So finally it's a over 2, 1 minus ax to the power of negative 3 over 2. And the first derivative from the statement f1 of x is, and just substituting 1 for n, we get a to the power 1, 2 minus 1, 1 factorial, and 1 minus ax to the power of negative 3 over 2, 2 to the power 1 and 0 factorial, which is 1, and we can see that it becomes a over 2, 1 minus ax to the power of negative 3 over 2, and it's clear that it's the same, so we can conclude that true for n is 1. The next step is, as usual, we write assume true for n is k, and just rewrite given statement substituting k for n. So assume true for n is k, fk of x is a to the power of k, 2k minus 1 factorial, 1 minus ax to the power of negative 2k plus 1 over 2, and 2 to the power of 2k minus 1, k minus 1 factorial. Let's check. And the next step is, as usual, we write for n is k plus 1, and we should consider fk plus 1 of x. And what does it mean? It means it's the same as the third derivative. It's what? It's the derivative of the second derivative. So derivative with number k plus 1 is the derivative of the derivative with number k. So we can say that it's derivative of fk of x with respect to x, and definitely we should what? Take the derivative of this. Notice that variable x is only here, and all these are constants, so it becomes a to the power of k, 2k minus 1 factorial, 2 to the power of 2k minus 1, and k minus 1 factorial, and again chain rule, so it becomes negative, let's write in front, and 2k plus 1 over 2, and 1 minus ax to the power of negative 2k plus 1 over 2 minus 1, and 1 minus ax due to the chain rule, 1 minus x derivative, which is minus or negative a. And minus minus plus a to the power of k plus 1, then 2k minus 1 factorial, 2k plus 1, 1 minus ax to the power of what? Let's do common denominator to 2k plus 1, since there is minus in front, so it's plus 2, so 2k plus 3 over 2. And 2 to the power of 2k and k minus 1 factorial. And let's consider what is our aim, what should we get. For n is k plus 1, we should get a to the power of k plus 1. It's already as required. And 2k plus 1, 2 multiplied by k plus 1 minus 1, you can see it's 2k plus 2 minus 1, just 2k plus 1. 2k plus 1 factorial. 1 minus x to the power of, again, 2k plus 1, 2 times k plus 1 plus 1, so 2k plus 3 over 2. 2k plus 3 over 2 with minus, yes, it's already as required. And about the denominator, it becomes 2 to the power of 2k plus 1 minus 1, it's 2k plus 2 minus 1, 2k plus 1. So there must be 2k plus 1, not just 2k. So 2k plus 1 and k plus 1 minus 1, k factorial. And what do we have? 2k minus 1 factorial, but we need 2k plus 1. But what is 2k plus 1 factorial? It should be multiplied by 2k and just 2k plus 1 to get 2k plus 1 factorial. Okay, and there must be k factorial, and we have k minus 1. So if we need 10 factorial, and for example when k is 10, and we have k minus 1, we have 9 factorial. To get 10 factorial, we should just multiply additionally by 10. So let's multiply numerator and denominator by k. Now this becomes k factorial as required. And we need 2 to the power 2k plus 1. To get plus 1, we need what? Additionally 2. So let's multiply the numerator and denominator by 2. So we multiply the numerator and denominator by 2k. And I rewrite, it's the same, 2k minus 1. I write this 2k here, 2k plus 1, just 2k plus 1, this 1 minus ax, negative 2k plus 3 over 2, and this becomes 2 goes to this, so it becomes 2 to the power of 2k plus 1, and k minus 1 factorial times k, it's just k factorial. So the denominator is as required, and we need 2k plus 1 factorial to be in the numerator, and you can see 2k minus 1 factorial. It's like 9 factorial, 10 factorial, and it's like 9 factorial times k times 11, because 2k it's the next number, 2k plus 1, it's 1 more, so eventually it's like 11 factorial, so it's the same as just 2k plus 1 factorial, so it becomes a to the power k plus 1, 2k plus 1 factorial, 1 minus ax to the power of negative 2k plus 3 over 2, 2 to the power of 2k plus 1, and k factorial. And now it's as required for n is k plus 1, so it's true. For n is k plus 1. And conclusion, if true, for n is k, true for n is k plus 1, since true for n is 1, true for any n is positive integer. And the next question, by using part A or otherwise, shows that the Maclaurin series for f of x, which is 1 minus x to the power negative a half up to and including the x squared term, is this. So just using a formula for the Maclaurin series, and it says that f of x is what? F of 0 plus the first derivative at 0 times x, and plus the second derivative at 0, x squared divided by 2 factorial, which is just 2, and plus so on. And hence it becomes f of 0, and it's clear that it's just 1. Then plus the first derivative times x, and at 0, and it's, you can use for n is 1, or just this, substituting what? 1 for n and 0 and 0 for x, and it becomes a over 2. It's 1 a 1 factorial and just 2, so it's a over 2 plus a over, let's rewrite more in detail. So f of 0 is 1, the first derivative of 0 is a over 2, and the second derivative at 0 becomes, and just substituting 2 for n and 0 for x, we can see that we get a squared, 3 factorial, and 1 factorial, and 2 to the power of 3. So it becomes a squared 3 factorial times 1 times 8 times 1 factorial, which is 3 over 4 a squared, and finally f of x becomes 1 plus a over 2x plus 3 over 8, because there is additionally 2 factorial, 3 over 8, a squared, x squared, and plus so on. Hence shows that 1 minus 2x to the power negative a half multiplied by 1 minus 4x. And you can see that it's actually the same, but for a is 2 and here for a is 4. So just substituting a 2 for a, we get that 1 minus 2x to the power of negative a half. So let's rewrite. So 1 minus 2x to the power of negative a half multiplied by 1 minus 4x to the power of negative a half is equal to 1 plus 2 over 2 1x and 2 squared 4, so plus 3 over 2 x squared plus so on, and multiplied by 1 and substituting 4 for a, 1 plus 2x and 4 squared 16 over 8, it's 2, so finally it's plus 6x squared plus so on. And we need up to and including x squared. So you try multiply each by each, and for this one, when 1 is multiplied by 1 we get 1 multiplied by 2x, it's 2x plus 1 times 6x squared, and higher powers of x which are not required. And for this x, when x is multiplied by 1 it's x times 2x is plus 2x squared, and that's all for x. And for 3 over 2x squared plus 3 over 2x squared, it's when this is multiplied by 1, and plus higher powers of x. And it is equal approximately, I write strictly and the dot or approximately and without dots, so it's what, 1 plus 3x and plus what, 8, which is 16 over 2 plus 19 over 2x squared, which is over 2 plus 6x plus 19x squared as required. Okay. D. Given that the series expansion for 1 minus x to the power negative a half is convergent for the absolute value of ax is less than 1, state the restriction which must be placed on x for the approximation to be valid. So we should consider just this to be valid. This minus doesn't matter because the absolute value, so 2x, the absolute value must be less than, strictly less than 1, and because we need they must be true together, so and at the same time 4x absolute value also must be less than 1. So absolute value less than 1, what does it mean? 2x is greater than negative 1 and less than 1, and at the same time 4x is greater than negative 1 and less than 1, and just dividing by 2 here and 4 by 4 here, we get that x is greater than negative 1 over 2 and less than 1 over 2, and at the same time x must be greater than negative 1 over 4 and less than 1 over 4, and at the same time x is what, greater than negative 1 over 4 and less than 1 over 4. It's because the first solution is from negative 1 over 2 to 1 over 2, and the second solution is from negative 1 over 4 to 1 over 4, and common solution is from negative 1 over 4 to 1 over 4. Or you may write the absolute value of x is less than 1 over 4. E. Use x is 1 over 10 to determine an approximate value for root 3. Give your answer in the form C over D, where C, D are positive integers. So since it is given that we should consider x to be 1 over 10, let's just substitute 1 over 10 for x. So it becomes 1 minus 1 over 5 to the power of negative a half, and multiplied by 1 minus 2 over 5 to negative a half, and it is equal approximately 2 plus 3 over 5 plus 19 over 100 over 2, and 1 minus 1 over 5, it's what, 4 over 5, and it's 5 minus, it's 3 over 5, and we can write it to common power negative a half, and it's what, and actually it's not required, to multiply. Why? Because negative power it's flipped, so it's 5 times 5 or 25, doesn't matter, 4 times 3 to the power of a half plus a half, and it is equal to what? It's square root actually, it's what? It's 5 over 2 root 3, and it is equal approximately, and we need simplify this, and common denominator is 100, moves down, and together with 2 it will be 200, but common denominator is 100, so it's 2 times 100, 200, plus 20 times 3, 60, plus 19. So 5 over 2 root 3 is approximately what, 279 over 200, and we need multiply by 2 and divide by 5, and we get 1 over root 3. So 1 over root 3 is approximately 279 times 2 over 200 times 5, and flip both sides, so root 3 is approximately we can divide by 2 to get 279 divided by 5. Flip vice versa, so it becomes up, so 500 divided by 279. Yes, it's correct. And that's all for this question.